Okay, in section 3.3, we're going to do division of polynomials and the remainder and factor theorems. So the objectives are to divide using long division, which is very much like the long division you've always done since elementary school. Divide using synthetic division, which is very easy to do, but there's only certain conditions under which you can use it. And then apply the remainder and factor theorems. And all this has to do with finding zeros of polynomials. That's why we're learning how to do this. How to find the zeros of larger polynomials, not just x squared, x cubed, but even x to the fifth, x to the seventh, and so on and so forth. So the division algorithm is you have f of x and d of x are polynomials. D of x can't be equal to 0 because you're dividing by d. The degree of d is less than or equal to the degree of f. If the degree of the denominator is more than the degree of the numerator, which f of x is the numerator, then you have a fraction, and there's no point in dividing it because it's less than 1. So let's look at, there are unique polynomials, q of x and r of x, that when you divide f and d, f divided by d, you get a quotient, q of x, and a remainder, which is the remainder divided by your denominator. You're not usually, typically when you divided, you didn't write it that way. Sometimes you might have, but you wrote like R1 or R2. Well, instead of that, you're going to write your remainder over the denominator, so that your remainder will be a fraction, as it's written in the quotient polynomial. And the polynomial is the dividend, f of x is the dividend, d of x is the divisor, q is the quotient, r is the remainder. And those are words that you have heard before, but you may not know. The numerator is the dividend, denominator is the divisor, your answer of the division problem is the quotient, and then whatever you have left over is the remainder. So to begin, let's use long division. But before we do that, I want to just remember what it was like to divide regular numbers. So let's say that you wanted to divide something like, say we're going to divide 357 divided by 3. Okay, so 3 goes into 3 one time. And then you multiply 3 times 1 and put your answer down here. Now you want to subtract it, so in essence you change the sign of it. Now if you got a number, you'd write it here, but we got a 0. And then you're going to bring down the next number. So since that 0 doesn't really count to anything, we'll take it out. But you bring down the next number. 3 will go into 5 one time. 3 times 1 is 3. Change the sign, add them, so you get 2. Then I'm going to bring down this 7, and 7 will go into 3, or 3 will go into 7 9 times, and so there's not a remainder. 9 times 3 is 27. There's not a remainder. So this answer could be written, this answer is written 119. If there was a remainder, it would be plus whatever your remainder was over 3. Our remainder was 0, so the answer is 0 over 3, or just 0. And so whatever remainder you have at the bottom, you're going to write as a fraction, and you're going to end up writing your answer. It will be a polynomial. So let's use their example. Excuse me. We're going to use long division to divide 2x cubed minus 11x squared plus 13x plus 15. And we're going to divide that by 2x minus 5. So we write our dividend, our division sign, and write our divisor, just like we did when we were doing numbers. Now you only look at the first term right now and you say, what times 2x will give me 2x cubed? And that would be x squared. Then you multiply x squared, you have to distribute it across both of those things. So x squared times 2x is 2x cubed, and then minus 5x squared. Then you change the sign and add. So you're going to change the sign, which becomes then minus 2x cubed and plus 5x squared. And so 11 plus 5 is negative 6x squared, and then you bring down your 13x. Then again, look at the 2x. What times 2x will give me 6x cubed? That would be minus 3x. You have minus 6x squared minus 15x. Change the sign all the way across. So you end up with plus 6x squared and minus 15x. And that's negative 2x plus, bring down your 15. And 1 times 2x, or negative 1 times 2x will give me negative 2x. So I multiply that negative 1 by both of the parts of the divisor. Negative 2x plus 5. Then you change your sign, so it becomes plus 2x and minus 5. And so our remainder is 10. And so the answer then, well, they just wrote the remainder of 10. Now let's use this one. We notice that the x cubed, x squared are missing in this one. Okay? So we're going to write them in there, but we're going to put a 0 in front of them because 0 times anything is 0. So we write in the missing terms. You always be sure you go in 5. In this case, you start with exponent 5, then 4, then 3, then 2, then 1, then your constant. We divide that by x minus 3. Well, x to the 4th times x gives me x to the 5th. Multiply by both parts of the divisor, change the sign, or subtract, so you have minus x squared plus 3x to the 4th. Those all add, that adds to be 0, and then we bring down a 0, we bring down another 0. So now we're going to bring down the 12x minus 33. And so 12 times x gives me 12x. And we have 12x minus 36, change the signs, be minus 12 and plus 36. So our remainder is 3 on this one. And this is how you could write that polynomial. X to the 4th plus 12 plus 3 over x minus 3. Your remainder over your divisor. And that's how I want your answers to be written. Alright, now this one's a little harder because we're dividing by an x squared. There's 3 parts to our divisor. So we have 2x cubed plus 2x squared minus 16x plus 32. Divide that by x squared minus 3x plus 4. So, multiply by 2x to get x squared times 2x is 2x cubed. So that's the first thing you put up in your quotient. Then multiply by all 3 of the parts of the divisor. 2x cubed minus 6x squared plus 8x. Then change your signs all the way across so you have negative, positive, negative. And then you add them up. Positive 6, the 6 becomes positive, so you have 8x squared. The 8 becomes negative, so you have minus 24x, and then you bring down the 32. Then I multiply by 8 plus 8, because that 8 times x squared gives me 8x squared. And multiply across everything. And when we change the signs all the way across, all of a sudden we have 0 as a remainder. So our answer is just 2x plus 8. There is no remainder. Now, this is a factor of the bigger polynomial. And you know that because there is no remainder. And we'll talk about that later in this period. So let's work this one ourselves. So we're going to say 4x cubed minus, there's not an x squared, so we're going to put plus 0x squared minus 23x plus 3. And we're going to divide that by 2x minus 5. Okay? 2x squared will multiply by 2x to give me 4x cubed. So we're going to write that down there. 4x cubed minus 10x squared This time there was an x squared term. In the last example there wasn't. Now I'm going to change the signs when I put parentheses and a minus. That means I change the signs all the way across. So the way I usually write this is to just go in and change the signs. If it's positive, I make it negative. If it's negative, I make it positive. These add to be 0, which they should. 0x squared plus 10x squared is 10x squared. And then bring down the 23x. 2x times 5x gives me 10x squared. So I'm going to say 5x times 2 is 10x squared, and then minus 25x. Whoops, I wrote 25x. Okay? Change the signs on the second, what we just wrote. This adds to be 0, and we have 2x. 25 minus 23 is 2x. And then I'm going to bring down the 3. Now, I'm going to add, it would be plus 1 at the top because 2x times 1 is 2x. So I have here, when I multiply the 1 by the divisor, 2x minus 5. Change the signs, and our remainder is 8. And so my final answer then is 2x squared plus 5x plus 1 plus my remainder divided by the divisor. And that's the final answer. Okay. All right. That's the one we just did. Okay. Now synthetic division. Synthetic division is pretty easy. But the only thing is, the divisor has to be just x to the first. You can't divide when you have an x squared or anything bigger using the synthetic division. If you do that, you have to use long division. So you have to have a binomial in the form x minus c. In this case, example, x minus 8. C is the constant. And so we've got x cubed, 13x squared plus 46x minus 49 divided by x minus 8. And the way you set this up, you write the value of c in a box. Okay, that's the constant you're dividing by. Now in this case, it's what x would be if you made that 0. So the value of, it's always the value of the factor. If I set the factor equal to 0 and solved it, that's the value you write in the box. You don't write a negative 8, you write a positive 8. Then I only write the coefficients, or the numbers in front of the variables. Alright? So, that's 1 is in front of the x cubed, negative 13 is in front of the x squared, then 46, then negative 49. Again, if there's missing powers of x, you have to put zeros as placeholders. So that's how you set this up. You take the opposite sign of the factor, and you write the coefficients that are in front of your descending powers of x, and be sure there's no missing powers of x. Alright, so here we've got this. Then you're going to skip a line and draw a horizontal line below the list of coefficients. Give yourselves room to write on that line, because you're going to do that. Bring down the leading coefficient from the dividend and write it below the line. So you just bring that first number down below the line, and that's going to be a 1. Then you multiply that by your divisor, 1 times 8. Okay, so 1 times 8 is 8, and you write it in the next column. And then you add that column. So negative 13 plus 8 is negative 5. You don't have to worry about changing the signs in this method. Then 8 times negative 5 is negative 40. You just keep repeating that till you're done. 46 minus 40 is 6. 8 times 6 is 48. and negative 49 plus 48 is minus 1. Now your last column is your remainder. Okay, so the rightmost number is your remainder. The other numbers below the line are the coefficients of the quotient in order by the degree of the term, but it's one less term than what you started with because you've done a division. So instead of x, we started with an x cubed, now it's an x squared. And so your final answer, you just read, and again, your descending powers of x, so you've got x squared x and then a constant. And now you can just read your answer, and those are your coefficients in front of those terms. 1x squared minus 5x plus 6 plus a negative 1 over x minus 8, because the x minus 8 was your divisor. So again, divide using the synthetic division, but notice now we have some missing powers of x. You're dividing by 3. You're going to write 1, negative 3, 0, 0, 12, and negative 33. And this is the same as our second example using long division if you want to go back and compare those answers. So draw your line, bring down your 1. 3 times 1 is 3. Add that up and you get a 0. 0 times 3 is 0. 0 times 3 is 0. 0 times 3 is 0, but now 12 plus 0 is 12. 3 times 12 is 36. Add them and you get a positive 3. Remember, the 3 is the remainder. Your 1, your first term is now x to the 4th. So you have 1x to the 4th plus 12 plus 3 over x minus 3. Okay, again, these x's are out of order. They're all there, but we have to put them in order. So we want to have reverse that x squared and negative 48x. We're going to divide by negative 10. So your coefficients will be 3, 25, negative 48, and 20. Be sure they're in descending powers, that you've ordered them correctly. Draw your line, bring down your 3. 3 times negative 10 is negative 30. Negative 30 plus 5 is negative 5. Negative 5 times negative 5 is positive 50. 50 minus 48 is 2. 2 times negative 10 is negative 20. And our remainder is 0. Since our remainder is 0, x plus 10 is a factor. It divides evenly into this polynomial. And so our answer is 3x squared minus 5x plus 2. Alright, so let's practice one. So we inspect and see we're missing an x squared. So we're going to write that our divisor is a 3. Draw our line and list our coefficients. We have 4, that's x cubed, 0x squared, negative 28x, and negative 7. We bring down the 4, straight down. 4 times 3 is 12. 0 plus 12 is 12. 3 times 12 is 36. 36 minus 28 is 8. 8 times 3 is 24. And 24 minus 7 is 17. And so remember, this is your remainder. We started with x cubed, so this is x squared. And then x, and then our constant. So our answer is going to be 4x squared plus 12x plus 8 plus 17 over x minus 3. And that's your final answer. Whoops, I didn't put my x. No, that's right. And that's your final answer. Okay? Now we're going to apply the remainder and factor theorems. And this part's fairly straightforward. If a polynomial is divided by x minus c, then the remainder is f of c. Okay, so in other words, if I put c into the polynomial and get a number answer, that would be our remainder. The value of c is the same as the remainder we get from dividing f of x by x minus c. So we have this polynomial. We want to know what f to the f of negative 1 is. If we divided this by negative 1, we would get a remainder of negative 1. If we plug negative 1 into the polynomial, if we plug f of 1 into negative 1 into the polynomial, let's do that. Then we say 5 times negative 1 to the 7th minus 3 times negative 1 to the 5th plus 2 times negative 1 squared and then minus 1. Well, negative 1 to an odd power is just going to be negative 1. So we have 5 times negative 1 minus 3 times negative 1 plus 2, 1 squared, negative 1 squared is positive 1, and then minus 1. So when we multiply, this will be negative 5 plus 3 plus 2 minus 1. 3 and 2 is 5. That cancels that one out. So my answer is negative 1. And you notice that I got the same thing, just plugging for the remainder. That's all it does for us, is tell us what the remainder would be. But I got the same thing plugging it in as I did if I did the synthetic division. And that's the remainder theorem. So we can find the remainder if we need to. And that's helpful because if the remainder is 0, then it's a factor. If it's not 0, it's not a factor. So evaluate the remainder for these. I think you should be able to do that. I don't have a calculator with me, so I'll just put, let's see, this for A, you would have 5 to the 4th power plus 5 cubed minus 6 times 5 squared minus 5 times 5 minus 15. Okay, I think 5 to the 4th is 625. Plus 125 minus 25 times 6 is 150 minus 25 minus 15. And if I've done that math right, if I add those all up, then I get the remainder if I divided this polynomial by 5. And then you would do the same thing with negative 3. Negative 3s are a little harder with exponents. In other words, I would have negative 3 to the 4th, so that would be 80. That'd be a positive 81 because it's got an even exponent. Excuse me. If I have plus negative 3 cubed, that's going to be minus 27 because negative 3 times negative 3 times negative 3 is negative 27. Minus 6 times negative 3 squared. Negative 3 squared is 9. 9 times 6 is 54, but it's negative. And then minus 15. No. Minus 5 times negative 3, which is going to be plus 15, and then minus 15. Okay? And so if I add these two, I get negative 81. These add to be 0. 15 minus 15 is 0. So the remainder of the second one is 0. So negative 3 is a factor or a solution for this polynomial. Which it says use the remainder theorem to show that square root of 5 is a 0 of this polynomial. And so you plug in square root of 5 to all of that. They did the division. Okay, so bring down your 1. This is harder problem. Multiply by square root of 5. And then you can't add those directly, you just have to write -4 plus square root of 5. Then when you multiply that by square root of 5, let me do that. Again, you have 4 times the square root of 5, and then, I'll do it off some here to the side. If I have the square root of 5, darn it. Okay, never mind. Let's go back. Okay. See if I can finally get this to, there it goes. If I have square root of 5 times -4 plus square root of 5. When this distributes, you get your -4 square root of 5. And then when this distributes, square root times square root is just going to be 5. And so that's where this number comes from right here. Okay. Then when you add those, this and this add to be 0. And so you end up with -4 times the square root of 5. And then to multiply that, you have -4, and then square root of 5 times square root of 5 is 25. I'm sorry, 5. And so -4 times 5 is 20. Okay? And so that'll be -20 here in the next slot. And then, so your remainder is 0. Excuse me. And that shows, when I get that remainder of 0, that shows that the square root of 5 is a 0. Therefore, as the 3 dots means therefore, the square root of 5 is a 0 of the polynomial. Complex numbers are a little trickier because you've got to multiply with I. And we've done that. We've worked with complex numbers, but they do make the whole thing trickier. Another thing to know about complex numbers is if you have one complex number as a 0, you always have another one. They come in pairs. So if one complex number is a 0, there are 2 zeros that are complex numbers. So we're going to see if 8i is a 0. So we write our coefficients. We divide by 8i, bring down our 2. Then we have 8 times 2 is 16i. And we end up with 1 plus 16i. And so I'm going to do this math out here again for you, just like I did before. So I have 8i times 1 plus 16i. Distribute, and you get 8i plus 16 times 8 is 128 I squared. And remember, every I squared changes to a -1. So you end up with 8i minus 128. Then you add the 128, and that cancels there. And you're just left with 8i. And 8i times 8i would be 64i squared. And replace that with -1. So the answer there should be -64. And when I write a -64 in here, I get a remainder of 0, which tells me that it is a 0 of this polynomial. Okay? So 8 is a 0 of the polynomial. I'm not going to work out these examples. I hope you can work those out. If you have any questions on this last part, though, be sure to ask me. Come by and ask me, or come to tutorials, and I'll help you out. The factor theorem: if f of c equals 0, then x minus c is a factor of f of x, which I've already mentioned that. We've already talked about it. if x minus c is a factor of f of x, then the remainder will be 0. Okay, so it's kind of works. That's just stating that same fact two different ways. So use the factor theorem to determine if x plus 4 is a factor. So what we're going to do, remember, since that's a factor in parentheses, I'm going to divide by the negative 4. I'm going to divide by the value of x. So I set up my division, make sure there's no missing powers of x, divide by negative 4, bring the 6, multiplies to be negative 24, adds to be negative 13, then that multiplies to be positive 52, negative 60 plus 52 is negative 8, negative 4 times negative 8 is positive 32, which adds to be 0. There is no remainder, so x plus 4 divides evenly into that polynomial, so it is a factor of the polynomial. And negative 4 is your 0. The factor is the opposite sign, because remember, in a factor, we look for the value of x when we solve it. What is the value of x that would make that factor equal 0? And so the factor x plus 4, but the answer, the solution, the 0, the root, whatever word you use for that, is negative 4. Okay? So let's do one of these. We'll do A. We have, we're going to divide by positive 6. We list our coefficients as 2, negative 13, 10, negative 25, and 6. There's no missing powers of x. We bring down the 2. 6 times 2 is 12. We add, get a negative 1. 6 times negative 1 is negative 6. You add and get 4. 6 times 24 is 24. You get negative 1. 6 times negative 1 is negative 6. And that adds to be 0. So x minus 6 is a factor. If you want to use the therefore symbol. X minus 6 is a factor, and x equals 6 is a solution, or a root. Okay. Okay, so this says factor this, given that x minus 6 is a factor. So we assume that x minus, we know that 6 is a factor, so we're going to divide. And then that gives me 4x to the 4th minus 3x squared minus 1. Okay? And so that would be my factors. X minus 6, and in parentheses, whatever's left over. If you can factor that more, and we'll talk about that when we talk about finding all the zeros, then we would keep going and try to factor that 4x to the 4th minus 3x squared minus 1. In fact, this one they did. They went ahead and factored and found that they could factor it. Now we know that x squared minus 1 is a difference of squares, and so we have x minus 6, x minus 1, x plus 1, and then 4x squared plus 1. So let's try this to factor A. So for A, they give us that negative 4 is a 0. So we're going to set up our division. And we've got 2, 7, negative 14, and negative 40. Okay? Bring down a 2. And that's going to be negative 8. When I add, I'll get negative 1. 4 times 1 is 4. It'll be positive, so that'll add to be negative 10. And negative 10, negative 4 is positive 40, which is 0. So now what I have is x plus 4. Because remember, when it goes into the factor, it's the opposite sign. and I have 2x squared minus x minus 10. Then I need to see if I can factor this with the x squared in it. So I need factors of 20 that will multiply to be, multiply to be 20, add to be 1. So it would be negative 5, 2x squared minus 5x plus 4x minus 10. Factor using grouping. Bring out an bring out just an x, and that will leave me with 2x minus 5. And here I'll bring out a 2, which leaves me with 2x minus 5. So I know factors of that one now. I still have this factor x plus 4. And I'm left with x plus 2 and 2x minus 5. And so then this is my answer right here. Okay? Once you get down to all linear factors, no powers of x squared, nothing higher than an x at any factor, you know you're finished. If as long as there's any higher power of x in a factor, you need to look to see if you can factor it anymore. You may not be able to, but you need to kind of double check and see. Write a polynomial of a degree 3 that has zeros, 2 of multiplicity 2, and negative 5. Alright, so you just write those as factors. A 0 of 2 would be x minus 2 as a factor. Multiplicity of 2 means it's squared. And then x minus 5 as a solution would be x plus 5 as a factor. Then if you need to, you can multiply all of that out, distribute everything, and get your final polynomial. Okay? Write a polynomial of degree 3 that has zeros 1/3, square root of 3, and negative square root of 3. Well, they didn't make that easy for us, so let's try that one. So we're going to have factors. We have f of x, that's our polynomial. And we've got a factor x minus 1/3, x minus square root of 3, and x plus square root of 3. Okay? Well, these, when we multiply, this is going to be x squared minus 3 when I multiply that out. And then I have to multiply by x minus 1/3. So we'll distribute the x across first. That'll give me x cubed minus 3x. Then we have minus 1/3 x squared, and then plus 1. Now, if I didn't want a fraction, I could multiply everything through by 3, or you could write x cubed. I'd write it in descending powers of x. And if you multiplied everything by 3, you'd have 3x cubed minus x squared minus 9x plus 3. And these two things are the same. One is just multiplied by 3, so you don't have a fraction. Okay, that's the end of the slideshow. And you have homework on Math Excel for school.